this video, we want to learn about the concentration, the idea of concentration. Now, I'm not talking about like, oh, let me think, play the game concentration. No, what we're talking about here is solution concentration. Now, what we're really talking about are unsaturated solutions. These are solutions that aren't saturated. So they're going to be clear solutions, all right? Now, they may have a color, right? They might be some colored solution, but they have degrees of concentration. So if it's a colored solution, you might have a less concentrated solution that looks like this, and a more concentrated solution that looks like that, and you'd see it darker in color. And you've had this experience. There's salt water, all right, water that tastes salty, and there's really, really nasty salty water. But it's really, really salty, and they're of different concentrations. So ultimately what this comes down to is some math. Is we can actually measure the concentration. Now there's two ways that we measure concentration in this class. There's more than two ways. There's something called molarity, and it's got a symbol capital M. And then there's one called molality. Sounds really similar, but it's just one word. And it's a cursive small m. All right? And let's talk about what each of these are. Well, actually, let's just talk about molarity. We'll talk about molality in a later video. So let's just focus on molarity in this video. And molarity is the moles of solute per liter of solution. Now, let's make sure we understand that. The moles of solute is like if I've got a beaker. Let's say this is salt in water, NaCl in water. The salt is the solute, right? And the solution is both of them together. And it'd be the liters of the two together. Not per solvent. Water's the solvent, but this is per solution. So if you know the moles and you know the liters, you take the moles and you divide by the liters. So let's do a couple of simple, easy problems. So example number one, you've got 2.3 grams of sodium chloride dissolved in 250 milliliters of water. All right, so I've got 2.3 grams of salt in 250 milliliters of actually water slash solution. So I want to get to what? Moles divided by liters. So what I'm going to do is I'm going to take 2.3 grams of sodium chloride over 1, railroad tracks, grams of NaCl per 1 mole of NaCl. Now where do I get this number? This is from the periodic table. Sodium weighs 23, chlorine is 35.5. That adds up to 58.5 grams of NaCl. The grams of NaCl can cancel, so now I have moles. Remember, I'm trying to get moles divided by liters. So right now I know the moles. And let me show you a little trick that I think is going to save you a lot of time down the road. So instead of like figuring this out and then dividing by the liters, this is what I would do. I would say 1 over 250 milliliters. Because I want to get the volume on the bottom. It's in the wrong unit, but now I've got moles per milliliter, and that's of the solution. And then I'm going to just do one more fraction. Let's erase this for a moment. And I'm going to say there's 1,000 milliliters, right? The millis have to cancel right here. In 1 liter, the milliliters cancel. And if you do the math here, let me get a different colored marker. If you do the math here, I've got moles of NaCl per liter. So I can just do one complete experiment. So let's go to our trusty dusty calculator here. And what I can take is I can take 2.3. Let's go to our trusty dusty calculator. I can go to 2.3 divided by 58.5 divided by 250 times 1,000. And I get 0.157. So this comes out to 0.157, and that's moles per liter. But we actually will write that 0.157 capital M for molarity. But remember, molarity means moles per liter. So our next example is how many moles in 0.135 molar, and you've got 125 milliliters of glucose, C6H12O6. So I've got three factors. From this we could get the molar mass, we go volume and mass. Now here's the real trick on this one. Capital M, you don't, when you do the stoichiometric part, you don't want to leave it in capital M. You want to break it into what it is. So I'm going to say 0.135 moles of C6H12O6 per 1 liter of solution. I just like to leave it just per liter. And I'm asking to find the moles, right? So the question is the moles. So I know this number. This is liters. I've got milliliters. Let's get rid of liters. I can say 1 liter is 1,000 milliliters, and my liters cancel. And if I then multiply, you see what I'm about to do here? 125 milliliters over 1, the millis cancel, and I get moles. Actually, so the molar mass, it didn't ask for grams. I just have to just do this. So back to my calculator, I'll take now, I'll clear it here, 0.135 divided by 1,000 times 125, and that gives me 0.017. So 0.017 moles of the glucose. Now, let's take this one step further. Instead of not just ask for the moles, but what if I asked for the grams? Now, if I was asking for the grams, hold on, let me erase this. You know what I would do? Is I would just erase this, and I would just keep going. I've got moles right here, and I want to get rid of the moles. I can do this way across the way, right? I can take the moles, I can say 1 mole of C6H12O6 is so many grams of C6H12O6. Now, I've got to figure that number. There's 6 carbons, so back to the calculator, right? So that's 12 times 6. Carbon weighs 12, plus 12. Hydrogen weighs 1. There's 12 of them. Plus 6 times 16. Oxygen weighs 16. So this is 180 grams. I'm going to redo this math. You'll see how this all plays apart. So I can take 0.135 divided by 1,000 times 125 times 180. And I get 3.03 grams of C6H12O6. Now, the reason that's important is that you're going to be asked sometimes in class to make up a solution, let's say 125 milliliters of a 0.135 molar solution of glucose. What are you going to have to do? You're going to figure out, you can't, there's no molometer, but there is a massometer, we call that a scale. You could mass out, right, get on the scale, right, the scales we've got, and a little weigh boat or whatever. You could have 1.35 grams of it, and then you would dissolve it into a flask containing 125 milliliters. Actually, you would put it in first and then fill it up to 125 milliliters, and then you could then make up a solution of a very specific concentration. In fact, let's cut to a video where I show you how to do that. So how do you make a solution from a solid? So here I have some copper chloride, copper 2 chloride, and I need to weigh out a mass. So I get my weigh boat, and I'll put it on a scale. You can see the scale right here. And you guys have done this multiple times, right? And I'm going to push the 0 button on the scale. Add some mass to this. And usually you'd calculate what the mass might be. I add a mass to it. So in this case I have, looks like 0.491 grams. And then to make it super accurate, we're going to add it to a volumetric flask. Now these volumetric flasks are like super duper accurate flasks, and they have just one line. You can see the one line right there. So now all I need to do is I need to then add this powder to this flask. Crazy simple. Now it's important that all of the substance gets into the flask, and if you look, there's some little green specks right here. So to get all of it into the container, what I need to do is I need to take the container right here, and I need to sort of scooch it this way, and I've got my squirt bottle, and I'm going to squirt, and then what's happening is it's squirting, I'm cleaning out the whey boat, and so then the water goes into the flask, or the special flask. Now I'm just going to add water, so I'm adding water. It kind of creates kind of a cool blue color right here. Once I get towards the tip, this is what I want to do, is I want to slow it way down, and I want to add water right up to the line, and I get myself just aim so I get it, and that it's actually the meniscus is at the bottom, right? And there I have made a solution. Now it's not completely mixed. I'm going to need to, mix it all up, but that's how you make a very specific, accurate solution. Put it on the scale, and then use a volumetric flask, fill it to the line. Folks, that's how you do molarity. It's crazy simple, and you just need to know, ultimately, moles per liter. If you know that, and don't just write, capital M. Break it apart into moles per liter, and then you can do the stoichiometry.